Assalamualaikum warahmatullahi wabarakatuh. So my name is Muhammad Hakim bin Muhammad Rabullah. Me and my group mate will explain about the importance of theoretical computer science in our everyday life. So the first one is cryptography. So cryptography is the practice and studies of techniques for secure communication in the presence of third parties called adversaries. So modern cryptography is heavily based on mathematical theory and computer science practice. Cryptographic algorithms are designed around computational hardness assumptions, making such algorithms hard to break in practice by any adversary. It is theoretically possible to break such a system, but it is infeasible to do so by any known practical means. These schemes are therefore termed computationally secure. Theoretical advance is available. Improvements in integer factorization algorithms and faster computing technology require these solutions to be continually adapted. There exist information theoretically secure schemes that probably cannot be broken even with unlimited computing power. An example is the one-time pad, but these schemes are more difficult to implement than the best theoretically breakable but computationally secure mechanisms. So I will pass to our next members.
Okay, so now we are going to go for the parallel computer architecture. Parallel computing basically is one of the another implementation of computer science theory. Parallel computing is basically a computation form of computation in which many calculation are carried out simultaneously. Basically a problem, a large problem, we will divide it into a smaller task, and then it will solve parallel in a parallel way. So usually, for the algorithm development and analysis of parallel architectural models, such as a mesh connected processors, hypercubes, and butterfly networks, have informed and shaped the design of many parallel multiprocessors machine that we have today. And the research on algorithm for routing in networks, including randomized routing, has also influenced the parallel machine design. So basically, and then we also usually we know that the programs that we want to write for the parallel computing are much more harder than the sequential one. Mostly because due to the potential bugs, which is known as race conditions. So I think that's all for me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mahanuddin and I will talk about how TCS can be used in software systems. Many software systems have incorporated ideas and algorithms first developed in theoretical framework. For example, evolving algebras have been used to specify language, e.g. C, Prolog, and VHDL, to define real and virtual architectures, to validate standard language implementation, and to validate distributed protocols. Versions of epistemic logic are widely used for the design and analysis of existing and new authentication protocols. Interactive theorem provide light proof power, a commercial power but based on an academic protocol, are used to verify properties of critical system. Coordinating Communication System (CCS) has been found to be an invaluable aid in the modeling, analysis, and design of safety-critical systems. Components of real systems involved in land and air transport, process control, and computer operating systems have been analyzed using CCS. Process calculi and related models logic has also been used, for example, to formally specify and analyze a cache coherence protocol for a multiprocessor architecture currently under development, to prove the correctness of a leader election protocol for point-to-point network, and to design and analyze a rendezvous-based scheduler to be used in the embedded software system. Thank you.
So computer science theory has helps develops in many of other areas such as, for example, learning theory. So computer science theory community has developed an algorithm that can learn subclass of finite probabilistic automata. So this algorithm has been successfully applied in a system that perform handwriting recognition, speech recognition, part of speech tagging, DNA sequence modeling, and text correction. So, learning algorithms and the technique for deterministic automata has been applied to reinforced learning, which promising a new paradigm for machine learning. And last but not least, learning algorithm for automata has also been applied to robot motion planning. So finding algorithm with better performance for this and other application motivate the search for new, more general subclass of automata that has efficient learning algorithm.